Hello everyone, I am Assistant Professor Kute Akshada from SND Engineering and Research Center. In previous lecture, we have seen ultimate analysis of code, and today we have discussed the significance of proximate analysis. In significance of proximate analysis, first moisture. Moisture decreases calorific value of coal largely as it does not burn and takes away heat in the form of latent heat. It increases ignition point of coal. Hence, a coal with lower moisture percentage is better quality. Second, volatile matter. It decreases calorific value of coal. It elongates flame and decreases flame temperature. It forms smoke and pollutes air. Third, ash. Ash reduces calorific value of coal as ash is non-burning part in a coal. Ash disposable is a problem. Ash fuses to form clinker at high temperature. Hence, lesser the ash percentage, better is the quality of coal. Fourth, fixed carbon. Carbon is burning part in a coal and higher the fixed carbon percentages. Higher its calorific value. Hence, a good quality coal contains high fixed carbon percentage. Significance of ultimate analysis. Carbon. Greater the percentage of carbon in coal, better is the coal quality and calorific value. Second, hydrogen. Most of hydrogen in coal is in the form of moisture and volatile matter. Hence, it decreases CV of coal. Smaller the H percentage, better is the coal quality. Third, nitrogen. Nitrogen does not burn during coal combustion and therefore it has a no calorific value. Hence, a good quality coal contains negligible nitrogen percentages. Fourth, sulfur. Sulfur can burn and increase calorific value of coal, but it causes SOx pollution and causes acid rain. Corrosion of metallic equipment. Lower the percentage of sulfur in coal, better is coal quality. Oxygen. Most of oxygen in coal is in the form of moisture. It decreases calorific value of coal. Lower the oxygen percentages, better is the coal quality. Next, petroleum or crude oil. Petroleum or the crude oil is dark greenish brown viscous liquid found in earth crust at the depth of few meters to 7 kilometers. Crude oil is the most important source of various liquid fuels used now, and a large number of petrochemicals can be manufactured from the crude oil fractions. The anaerobic bacteria, higher temperature, radioactive matter make the degradation of organic matter in the presence of water under the dome to highly alkenes which matter as crude oil. The anaerobic bacteria take out oxygen from atoms. Next, composition of petroleum. Average elemental composition of petroleum crude is carbon is 80 to 87 percentage. Hydrogen is 11 to 15 percentage. Sulfur 0.1 to 3 percentage. Oxygen 0.1 to 0.9 percentages. Nitrogen 0.4 to 0.9 percentages. Petroleum contains following types of compounds: open chain alkanes, cycloalkanes, aromatics, asphaltanes, resins. First, open chain alkanes. Both straight chain and branch chain alkanes are present in crude oil. In some crude oils, such alkanes part is major. Second, cycloalkanes. Crude oil contains cycloalkanes like cyclopentane, cyclohexane, and their alkyl substituted products. Some crude oils contain dominating amount of cycloalkanes. Aromatics. In all the crude oils, benzene and alkyl substituted benzenes are up to 2 percentages. Asphaltanes. All the crude oils contain the small amount of polycondense aromatic solids as colloidal depression in crude oil. The asphaltanes also contain nitrogen, sulfur, oxygen atoms. Next, resins. These are the polymeric substances. They are gummy and are lower molecular weight of polymers. Next, refining or fractionation of petroleum. In the fractionation of petroleum, crude oil cannot be directly used for any purposes. Refining or fractionation is the process of separation of various fractions from crude oil on the basis of fractional distillation. The crude oil contains a large number of hydrocarbons, but by the process of refining, they are divided into few groups of molecular weights or boiling point ranges. The refining consists of removal of water. First, the emulsified water along with salts dissolve it removed by passing the crude oil between highly charged electrodes. Removal of sulfur. Then the crude oil is treated with hot CuO to remove sulfur from the sulfur compound in crude oil. Fractionation. The principle of fractional distillation is that the vapors of higher boiling point compounds first get condensed into liquid during the stepwise cooling. Various useful fractions like petrol, diesel, kerosene, etc. are obtained by fraction. Construction of fractionating tower. This is a structure of fractionating tower. Fractionating tower contains at the bottom residues. Above the residues contains heavy oil on the top of uncondensed gases. The refining is carried out in a tall cylindrical tower called as fractionating column. The fractionating column is a tall cylindrical stainless steel tower about 30 meter in height and 30 meter in diameter. There are 50 to 60 horizontal stainless steel trays at about half meter distances in the tower. Each tray is provided with 4 to 5 bubble cups with loose caps so that the rising vapors through the cups bubble in the liquid deposited on tray. Fractions are taken out from bubble tray only, not from all. Such trays are known as draw-off plates. Temperature of the tower is 400 degrees Celsius near bottom and it decreases gradually to 40 degrees Celsius at the top. The tower is cooled by open air. Working of fractionation. The crude oil is heated at about 400 degrees Celsius in a furnace or pipe still to convert it into vapors. The vapors enter into the fractionating column at the bottom. The vapors travel upwards through the bubble cups and gradually get cool. The vapors of organic compounds with higher boiling point get condensed in bubble cups and the liquid deposited on the trays. From some bubble trays, the fractions like petrol, kerosene, naphtha, heavy oil, etc. It is possible to convert any higher boiling fraction into petrol of LPG by the process known as cracking. Further, the naphtha material is also obtained in larger quantity than required. It can be converted into petrol by catalytic reforming.